Thank you. I think we have a little bit time for questions. We are right on time. There was half an hour of coffee break, so if we reduce it with 10 minutes, we can have some questions.
Yeah, thank you. I have a question regarding the Connective project. What is the link with the Links for Rail project, which aim at developing a common data model and ontologies?
Is it working? Yes.
Hi. Well, in particular, Connective doesn't have any connection with the common data model of Links for Rail. The project that I mentioned on the beginning, called Extensive, is the one that is linked to Links for Rail and the common data model. So in the case of Connected, sorry, but it's not linked.
Are there other questions? Yes.
This question is for the SNCF colleague. Just now you mentioned that currently in the train, maybe it will take like 6 minutes or 2 to 6 minutes to get the train's location, or you may not even get the speed. Can you talk a little bit, what is the reason for such a long delay, and from your perspective, anything can be done here?
Okay, so it's not a question of latency. It's a question of, today we detect trains by pedals on the track, at least at the SNCF Réseau, or on smaller lines by the signalers seeing the trains go by and say, well, the train has been at this station at 12 hours, 32 minutes. So that's why we only have the pedals in stations, not in the middle of a line between two stations. So this is the reason. Yeah.
Even on the main lines, where on every signal, if there is already a feedback loop, it's also taking 1.5 kilometers. So it's also not accurate. If you really want to have a good conflict prediction, it's better to have it on seconds. So if you know exactly every 20 seconds, as Sébastien said, where the train is and its speed, it's much easier to predict when it will reach a possible conflict. Other questions? If not, I have a question to the Meteorological Institute of Italy. Have you checked other possibilities, or what's the best way on increasing the energy efficiency and having less losses? Have you checked also, for instance, having a small battery on board?
Yeah, actually, in general, we perform measurement to see if the results of simulation are correct. But of course, the timetable is the best option for the moment. But not only installation, of course, of reversible substation, but in our opinion, we think that a coordination of the voltage, it's a key point, because, for example, I don't know if you remember the voltage statistic measured at the pantograph. The voltage was quite high during the normal operations, and when, let's say, a braking occurs, the voltage starts to grow, but it can grow up to a certain threshold. Then the braking starts to be mixed and then purely dissipative. If we lower a bit this value of the constant voltage, maybe we have, let's say, a better distance between the nominal voltage and the threshold voltage, so we can recover more energy, of course.
Thank you. I've checked in Belgium on if it was interesting to add a reversible substation. Just taking as your measurements, but then taking it at the substation level. If you see that on the moments that you reach the 3.8 kilovolt in Belgium, because the 3.9 is not officially permitted yet due to some older trains. If on that case you still have energy going from the public grid to your overhead contact line, reversible substation has no advantage.
Yeah, exactly.
And that was, okay, it's 5 years ago, but that was not, I didn't find any substation where there was a significant advantage of a reversible substation. If it's only suitable on the last trains in the day, okay, then actually, it's not, investment is too high for the benefit.
We performed some measurement in Metro de Madrid, and we noticed that the reversible substation works more when the number of trains is low. Because, of course, in that case, there are not many trains that can use the energy provided by the braking, so in that case, it's fed back to the main grid, of course. But
we still have time for questions.
So it was a question for our colleague from Mitsubishi. So the applications you presented on the millimeter wave, how will they be integrated in FRMCS? So will it be something standard, or will it be limited to specific applications where you need a specific deployment?
Yeah, so currently FRMCS studies are limited to FR1, so regular bands, so 900 megahertz and 1.9 gigahertz. So to my knowledge, there is no work addressing millimeter wave bands yet. But for sure, all the use cases that we presented in the later slides should be addressed, in my opinion, in the future FRMCS work. But currently, there is no plan for this.
Thank you.
A question on the back.
I have a question to you, Mr. Dessler, about the SFERA. First of all, do you have any experience already from the projects that you mentioned about the data quality? Standard and data format is one thing, but data quality infrastructure-wise yet another thing. And the second, how many traffic managers in Europe are already in a position to send capacity information and live conflict information to some sort of applications?
Okay, so I'll take the questions one by one. For the data quality, so the protocol itself doesn't handle the data quality because the SFERA project is just, the messages themselves. So for data quality, it is the main hurdle for infrastructure managers to deploy it. So in some countries, it's been, when we talk about CFL, it was perhaps an easy country where when you've deployed ETCS as a you also have it's very digitized on the data infrastructure. So it must have helped them to be one of the first to deploy on the whole network, even if it's a few hundred kilometers long. But yeah, it's a main hurdle. Yeah. But the idea is that SFERA is built with evolution in mind, where you can start with a minimal data set and build up to get more precision and add more functionality. And also, as we're working on at SNCF Réseau, we have a rather extensive network, and the SFERA protocol helps us be able to do full CDAS operation on some parts of the network where we have good data quality, but still send a reduced data set on other parts of the network where we won't have full CDAS possibilities, but at least driver gets information for the whole trip. So from the, let's say, user standpoint, it helps him to adopt the tool and start using it instead of having something that works for 1/3 of his mission and then doesn't give anything more. And the second question was on... so I don't really have the numbers because we haven't, well, at SNCF Réseau we haven't deployed it yet.
Conflict detection, it certainly CFL has. And as there are 3 countries starting with a CDAS-C or having an old legacy CDAS-C, they also need some conflict detection. So ÖBB, SBB, Infrabel has some conflict detection. Another way on giving information back from trackside to board is the way that ProRail is doing, is giving the occupation of the blocks in front and behind the train, and also DB is giving this information. It's not the ideal, it's not a real conflict detection, but it's saying what's running around you, and then your intelligent apps can maybe do something with it.